Hello, we are a team of mechanical engineers attending Cal Poly SLO. We are team number 3004. My name is Ashley Humpal.
Hey guys, my name is Keanu Robin.
I'm Kyle Chuang.
Hey, I'm Christopher Tan. We are participating in the 2021 Design Challenge hosted by Source America.
In this design project, we were given a general scope about creating a kitting workstation to address certain disabilities. To begin with, we conducted some background research. We interviewed multiple people that have experience working with people with disabilities in the kitting and packaging field, including the CEO of VTC Enterprises and a representative of North Bay Industries. And after speaking with these individuals, it led us to focus on the human error side of the project and try to account for that. After looking closer at the kitting process, we identified multiple issues. Workers may have issues holding bags open and placing items in them or folding paper instructions. Most of the issues we identified were more focused on dexterity issues, so we decided to narrow our scope to focus on that. We want to help increase efficiency and increase quality assurance for these workers through our kitting station.
After our design iterations, this is the final design we came up with. It still incorporates a top-down workflow that starts with the user manually placing items into the holes in the top template. We've also included an adjustable mirror to help with this process. Then, the user pushes in the handle, which allows these retractable hooks to grab onto the bags and hold it open. Then this knob is pushed in, which aligns the holes in the top template and allows the items to drop down into each one of the bags. Then the heat sealer handle is pushed in all the way, which seals the bags and then cuts them using these blades. Then the handle is retracted and all the bags drop down into this accessible area where the worker manually places labels on each bag. Then it is consolidated into this funnel, which drops down into the final bag. We've added this additional optional tool to help with the paper folding for the paper instructions. After it's folded, we place it into the top funnel, which also drops it down into the bag. Then it is sealed using a similar system and then dropped down onto this scale where the weight is read as a final test of quality assurance. To repeat the process, the bag cranks are actuated using ratchets and the cycle continues. Our design is beneficial to the user because it simplifies all the complicated movements involved with kitting and packaging these items into simple push-pull movements, which greatly reduce the amount of required dexterity for the user.
This is our first design that implemented a top-down system, so only one workstation is needed. We also implemented the base requirements for the kitting and packaging design challenge. It also consists of hooks to grab the bag, heat sealer, and push-pull movements that allow it to be used left or right-handed by the users. This is our second design. After peer review and feedback from our coach, our first design was too tall, therefore users can't sit when operating the workstation. We modified our design, therefore the final bag column will be placed on the far right column where users can drop the bag items into it.
Here we have our third design. Due to the bag rolls being too far back in the previous design, we felt that the cranks were too far, which would lead to an uncomfortably far reach for the user. So one of the key changes we made was moving the bag rolls to the top of the system. With this change, we added a mirror right above the sorting template to give the user a better top view of the template. Here is our fourth design. For this design, we had to update the cranks connected to the bag holding shaft. The reach was still farther than we'd like, so we changed it into a long crank as opposed to a small handle at the top. Another change we made was the handle on the sorting template. Originally, we had the handle on the left side, but with the long cranks on the sides, the handle would obstruct the movement of the left crank.
After we finalized our design, we built a structural prototype as verification that our key components like the bag roll, sorting templates, funnel, and heat sealer would all fit in our workstation. From there, we further prototyped our heat sealing system by putting the handle on tracks and making the heat sealer actuated using a 3D printed pushrod assembly. Then we implemented it into our structural prototype and tested its feasibility by bagging miscellaneous items like the paper clips shown in this video. As you can see, the heat sealer is able to seal the bags while requiring minimum effort from the user.
And that was the extent of our prototype thus far. We'd like to thank everyone for taking the time out of their days to watch our video. The design process does not stop here. We plan to continue building the prototype as well as testing the individual systems to ensure proper functionality throughout the entire design. Please like, comment, and share this video. And on behalf of our whole team, we would like to thank Source America for this opportunity to display our engineering skill set through helping workers with disabilities.